absorption refrigeration system. Okay. Vapor absorption refrigeration system. And here, once again, I insist you to start with the evaporator coils. I insist you to start with the evaporator coils. Okay. And now please look here. The refrigerant which is entering the evaporator coil will be at low temperature, low pressure, liquid refrigerant. Low temperature, low pressure, liquid refrigerant. Now, when it enters the evaporator coils, while circulating in the evaporator coils, what happens? From this cabinet, the heat of this evaporator will be extracted or transferred to this refrigerant. Due to this, what happens? This refrigerant will become vapor. This refrigerant will become vapor. So that the refrigerant which is coming out of evaporator will be at low temperature, low pressure refrigerant, vapor refrigerant. Okay. Now here, before that, I wanted to tell you what is this absorption refrigeration. So some fluids will be there. Those will be when you some of them will be dissolving in some of the fluids, and while dissolving they'll become stronger. So here the water and the NS3 are two things we have taken. This water will be a solution and the NS3 is a refrigerant. The NS3 will be dissolved in the water and it will become stronger. This is the theory behind this. Okay, when the NS3 is dissolved in water, it will become stronger. This is the theory behind this. With this, we will try to explain or we'll try to discuss this. Now, before I take all these into a very systematic way, I'll try to make you to understand. Now here you see there is a absorber. The main thing, the absorber, what happens is here, there will be a water. There will be a water, and you can see that at this particular place, once it is heated up, what happens? The NS3 vapor will be separated and the weak solution of ammonia. That means to say the weak solution of ammonia is it will be along with the water, and this is made to flow to this absorber. Now heat, part of this heat will be taken for the heat exchanger purpose. Part of this heat will be taken for the heat exchange purpose. Otherwise, the additional heating coil, it will be increasing the power requirement. Only the power requirement will be at the heating coils. There in the vapor compression refrigeration, the compressor, to run the compressor, we were using the okay, to run the compressor, we were using the electricity. And here to heat the coils, heating coils, we are going to use the electricity. Okay. Now let me start with the evaporator coil. Here in the other case, there the evaporator coils were there. Don't get confused. These evaporator coils are those. Here it is maintained in a cabinet, and this particular portion has to be kept at low temperature in the refrigerator place. Now the low pressure, low temperature, liquid ammonia or refrigerant, you say ammonia or refrigerant, which enters the evaporator and which will be extracting the heat from the cabinet. After extracting the heat from the cabinet, the refrigerant will be at low pressure, low temperature vapor. This low temperature, low pressure vapor enters this absorber here. Please remember, it is vapor absorption refrigeration. It will be entering the absorber here. And already the weak solution from the generator is entered this absorber, and when it is mixed with this weak solution, it will become a stronger solution. Once the ammonia is absorbed by the water, then it will become a stronger solution. This stronger solution at low pressure, slightly it will be attain slight heat, but I'm not telling it is heated up. Okay, the low pressure, low temperature, strong solution. The low temperature, low pressure strong solution will be entering this pump. This pump may be a screw pump or simply a pump, vane pump. And when it is entering this and coming out of this point, what happens? It will be at low temperature, high pressure liquid refrigerant. It will be low pressure, low temperature refrigerant, liquid refrigerant, stronger solution. It was here. Now at this point, when it is coming out of pump, it will be at high pressure. Now it is made to flow through this heat exchanger. At this heat exchanger, the heat of the strong solution which is coming from the generator, which will be entering the observer, here heat of this will be transferred to these coils and it will become a hot. That means the temperature of this strong solution will be increased. So the solution which is coming out of this heat exchanger will have high pressure, high temperature, strong NH3 solution. Okay, this high temperature, high pressure, strong NH3 solution enters the generator. The meaning of generator is that it will be generating or it will be separating the NH3 vapor and the weak solution. Now please look here. At this point of time, here the heating coils will be there. Due to this heating, what happens? The NH3 vapors will be separated out. The NH3 vapors will be separated out and the weak solution again it will be transferred to this absorber and this closed circuit will be continued. This closed circuit will be continued. Then to the condenser, while it is flowing, it will be a vapor, high temperature, high pressure, vapor refrigerant. It will be high temperature, high pressure, vapor refrigerant which enters the condenser. And the main function of the condenser is just like the operator only. At the operator, the heat will be extracted. At the condenser, the heat will be given out from the solution. So at the condenser, what happens? Before it enters, already it was high pressure, high temperature, NH3 vapor. Now it will be coming out as high pressure, low temperature, NH3 liquid. It was vapor here. After it is giving out the heat, it will become a liquid. This high pressure, low temperature, NH3 liquid is made to expand through this expansion device and it will be at low pressure. Again, it will be continued in the circuit. This is about the vapor absorption.